Privileged access is where infrastructure risk becomes real. In this section, we'll secure admin pathways into cloud, Kubernetes, databases, registries, and production AI systems using PAM, just-in-time access, approvals, monitoring, and auditability to reduce blast radius. So far, we've built from identity foundations into applications, data, cloud, Kubernetes, workloads, and AI access. Now the focus shifts to the people and services with the power to change production. Privileged users, operators, emergency access, and the controls that govern them. AI infrastructure access is powerful because it cuts across every layer of the system. An administrator may never touch the application directly, but still reach secrets, training data, Kubernetes workloads, CI/CD pipelines, vector stores, GPUs, or model registries. Unmanaged privileges can bypass application controls and affect confidentiality, integrity, availability, and model behavior. In a zero-trust AI architecture, infrastructure access must be governed, monitored, and limited to what each role truly needs. Think of PAM as the control plane for administrator power. It discovers privileged accounts across cloud, servers, databases, pipelines, and platforms. It removes standing password knowledge by vaulting secrets and brokering access. Users request what they need for a limited time, often with approval. Credentials rotate automatically after use. And because privileged actions are high risk, sessions are recorded, audited, and available through break glass only when operations truly demand it. Effective control starts with knowing every privileged identity that exists. That includes named administrators, cloud roles, Kubernetes cluster admins, database superusers, CI/CD deployers, service principals, workload identities, automation tokens, API keys, and model pipeline credentials. Each identity should be classified by scope, environment, data sensitivity, and business impact. The inventory must stay active, continuously flagging orphaned, unused, overprivileged, or shadow admin access before it becomes an attack path. Credential vaulting changes privileged access from who knows the password to who is allowed to use it right now. Secrets stay protected in the PAM vault, including passwords, SSH keys, API tokens, and emergency accounts. The admin authenticates with SSO and MFA, submits a reason, and may need approval. If policy allows, the vault brokers access or checks out a temporary credential. After use or on schedule, rotation replaces it, limiting reuse and persistence. Privileged access should not mean unlimited freedom. Once a session starts, PAM can evaluate sensitive commands in context: who is running them, which system is targeted, the environment, the risk level, and whether a maintenance window is active. Low-risk actions may proceed. Dangerous actions, such as disabling logs, modifying IAM, deleting namespaces, or dropping tables, can be denied or routed for approval. For the highest risk commands, step-up authentication, alerts, and automatic blocking enforce policy at execution. Break glass access is the emergency path for moments when waiting would create greater risk, such as an outage, compromise, or administrator lockout. The goal is to make it exceptional, not convenient. A user must strongly authenticate, state why access is needed, receive only temporary elevation, and trigger immediate alerts. Every action should be monitored and recorded. Afterward, teams review whether access was justified, what changed, and whether credentials or controls need rotation or improvement. Just-in-time access changes admin privilege from something people permanently have into something they temporarily earn. An administrator requests elevation for a specific task, system, and time window. Policy checks identity, risk, approvals, and environment sensitivity before access is activated. When the task ends or the clock expires, privileges are removed automatically. The benefit is straightforward: fewer standing permissions, smaller exposure windows, and less opportunity for credential theft or privilege abuse. A mature JIT IT workflow begins with enterprise identity, SSO, MFA, and a verified user request. The policy engine checks approval, context, and risk, then activates only the exact role needed, such as a cloud IAM role, Kubernetes admin permission, or AI platform entitlement. Access exists for a defined window, maybe 60 minutes. Every action is logged. When time expires, privileges are revoked automatically, and monitoring confirms the cleanup actually happened. Approval should match risk, not depend on one gate for every request. Routine actions like reading logs in a safe environment can be auto-approved by policy. Production changes, data exports, model promotion, and IAM updates deserve stronger review. The decision should account for device health, location, anomalies, time of day, and past behavior. Every elevation also needs an audit trail: reason, ticket, scope, duration, and approver. Privileged session monitoring turns admin access into an auditable, searchable record. Whether the user connects through SSH, RDP, SQL, Kubernetes, or a cloud console, the session broker captures commands, keystrokes, screen activity, identity, timestamps, and target details. That telemetry supports alerting, so actions like deleting logs, changing IAM policies, disabling controls, or opening sensitive data can be flagged quickly. The same evidence is preserved for investigations, compliance reviews, and incident response. Risky administration is not limited to someone running sudo. In AI systems, a privileged action can change a model, poison a pipeline, expose embeddings, or weaken audit controls. Detection should combine two lenses: known dangerous actions, such as policy changes, secret access, exports, and log deletion, and behavior that deviates from normal, such as after-hours access or unusual command sequences. Correlate signals across cloud, Kubernetes, database, CI/CD, and model registry logs, then prioritize by impact. In AI operations, the safest pattern is to make powerful actions shared responsibilities. The person who builds a model should not be the only person approving its release. The person changing access or guardrails should not be the only checkpoint. Separate roles for data ownership, security approval, deployment, and audit reduce conflicts of interest. Dual approval adds friction where risk is highest. Workflow tools, policy engines, and audit logs then prove the controls actually happened. Infrastructure access security comes down to 4 habits: centralize privileged control, grant access only when needed, monitor every sensitive session, and require governance for high-risk AI actions. With PAM, JT, recording, and dual approval in place, you are ready to validate the controls continuously and design the secure architecture.